Hello everyone, my name's Louis and I graduated year 12 in 2024 and achieved a score of 50 out of 50 on the physics external exam. And so I'm here today to talk about my thought process going through these papers for externals to help you as students to achieve the best possible mark that you can. And so with physics, today I'm just going to be going through the multiple choice question book, and I was pretty confident overall with how I went in the exam with the multiple choice question book. I'm pretty certain that I got 100%, otherwise I wouldn't have got the 50 for the external. But here I'm really just trying to show you how to get those marks. And yeah, so I'll just go along. I've put the formula sheet next to the actual exam on the left hand side that we're going through, just to help as well. And some of these like additional helpful resources and images that I'll talk through about them, and they're also for you to complement your study relating to these questions, but obviously they won't be showing up on the external. It'll just be the question, the 4 options, and you have to pick. Right, so question 1. Which option describes a feature of baryons? So we know that baryons, it's not necessarily on this image right here, but it's really about, in terms of standard model, how I learned it is really just rote learning, using lots of tables to summarize information. And I guess also, if you want to try process of elimination in these sort of multiple choice questions, so think of baryons, think of 3 quarks, okay? So that's easily our answer. If you want to use process of elimination, to be honest, I've never heard of positrons before, so I can immediately cross out that as a red flag. It's a type of elementary particle, not necessarily, because baryons, they're like 3 quarks, so they're like 3 elementary particles. I guess a type of elementary particle would be something like the individual quarks themselves, or the leptons, or the gauge bosons, and stuff like that. You don't need to know anything about Higgs, and yeah, I think that's the only one you don't need to know. Everything else you should have an understanding of, and take note of the charges as well. And I like these tables, how they're organized, because you can sort of, I guess, they make sense in a way. Like up, down, they would be 2/3 charge for up, and then -1/3 for down. It's like, and then it's the same charge for each of these elementary particles in their rows. So up, down, charm, strange, top, bottom. Okay, up and down and top and bottom make sense because they're like opposites. Charm and strange, you just have to note that. And then same with these leptons that are negatively charged, because they're not neutrinos. They have a -1 for all of them. And neutrinos, they have a neutral charge, but they're just basically with a V and then subscript of that letter. And anti-quarks are basically where you just flip the sign of the charges. So you can see this is now -2/3, and this would be +1/3. Okay, and then I don't think you need to know the charge of the gauge bosons, but just know the 4 gauge bosons in general. So like gluon, photon, Z, and W boson. Yeah. So what I did during my study in year 12 is I had this diagram printed out, and I literally just put it on my MacBook or laptop on the near next to my keypad. So I printed it on a small version of it on an A4 piece of paper and just cut it out. And then I also put this on my wall of my bedroom, and so every day I would literally look at it and just see some patterns, like what the charges are and what the different symbols are, and it just doing that sort of sticks to your head. Then notice how there's like what is here? You have the lines up here to show that they are anti, and you have a opposite charges, so these are now +1 for the leptons, so E plus, E minus, T, tau, anti-tau, and stuff. So it's just a helpful tip there. And question 2, moving on, is which property of light is described by the postulates of special relativity? So really, I'm pretty sure this is one of your dot points in the QCAA syllabus. So really, in physics, I would just recommend going by the dot points one by one, making sure you know how to answer them fully and correctly as well. So you can definitely get a postulate of special relativity question because it is one of your dot points. All right, and so when I thought of the postulates of special relativity, I literally just wrote it down. So one is all laws of physics are the same. So it's also above in this photo here, but I'll just like to rewrite it. So all laws of physics are the same in all inertial frames of reference. Inertial just meaning that we have a constant v, which can also mean at rest because v is just constantly 0. And then 2 is the speed of light in a vacuum, blah blah blah, is constant. I'll just say constant. Okay. Regardless of any motion of the source or observer, the speed of light is always constant. And so that obviously have implications with time dilation, length contraction, and stuff like that. Because if you're moving at those relativistic, or in other words, close to the speed of light velocities or speeds, if you're traveling in those speeds, then that means you're going to view light differently in your frame of reference. But we'll get to that later. There's a couple of questions on that. So you can see it's not about the energy of light that's greater, not about the frequency. Nope. So we can cross out these variables, not relevant. Wavelength of light decreases. No, we're not talking about wavelength. Velocity of light remains constant in all inertial frames of reference. Yep, that's my green flag there. Okay, and then if we want to check D, frequency of light changes depending on media. No, it's really, the postulates are really about constants. C. Okay, saying that things are the same. So the two main things that are the same are the laws of physics and the speed of light. Okay, cool. So that's our answer there. I'll check these as we go. Okay. Now, another tip I have, which really helped me get the result I got, was using this method called the 5 Fs, which was taught by my own physics teacher. Now the 5 Fs basically stand for facts, figure, formula, find, and finalize. Okay, so I'll go through them. I'll show an example of how to use them in this question rather than explaining what they mean. So facts. Okay, we have two objects with masses 65 kilograms and 75 kilograms respectively. Okay, so, and are separated by 1.50 meters. What is the gravitational force of attraction between them? Okay, so facts. And this is also really good in terms of if you want to get full marks on those short response questions as well with calculations, because often you'll be marked on facts and a figure, which is sometimes left out and people just go straight to the formula. Okay, but sometimes you have to convert values and you get marks on simply just converting your units to the correct value. So you don't want to be losing marks, you want to be gaining marks because of how easy they can be. Just simply writing down or repeating the question in your response. Right, so if this was a short response question, this is what I would do. I would write my facts down. So I know that, and I'll write it in green, just so it's a bit different to the notes I have on the side. We know that mass, one of the masses is 65.0 kilograms, and another mass, which I'm going to say is capital M, is 75.0 kilograms. Okay, and they are separated by 1.50 meters, right? So I know that meters is a distance or length, and I can just put R down for that. So R equals 1.50 meters. And I know that G is the gravitational constant, all right, which is, if I look at my formula sheet, because I've practiced and I know where these things are to save time, it's 6.67 times 10 to the negative 11 and these units here. But I mean, you can write the units, it's probably best practice too, but for the sake of what I used in the exam, I already know that any constants that I have here will always be, if I keep everything else into SI units, then I know that they're just going to cancel out anyway. So, and another thing is, because I've been, when I was studying, I was very let me say, like, very familiar with these constants. I could just memorize them and say them out loud, like by word, without having to look at the formula sheet. It also saves a lot of time. So that's why it's important to practice or either memorize them yourself. Okay. And so we're also trying to find what F is, because I know that gravitational force in the glossary of physics QCAA syllabus, which is in chapter 6, I know that is the symbol for that is capital F, and the units, SI units, is going to be newtons. Right? So we have capital F equals question mark capital N for newtons. Right? Cool. And then from that, we're now up to step 2 of the stage figure, and I would just draw 2 masses with labeling what the key features of them. So M equals 75 kilograms, and another big M, just different, it's 75 kilograms, 65, 75, and we have a separation of distance 1.50 meters. Okay, noting that everything is in my SI units. Okay, and I know the constant is 6.67 times 10 to the negative 11. Okay, and then from that, I now try and find a formula that's relevant. So I immediately know that I'm going straight to gravity in motion, because, you know, done lots of practice. I know immediately where to go on the formula sheet, so I'm not wasting time. Right, and I can see this is the formula that uses all the variables that I need. Where I need to find F, I got G, I got M, I got another M, and then I got an R. Alright, and it makes sense because this F is referring to the gravitational force. Alright, so easy for me, I don't have to transpose or rearrange my formula. Okay, and there we go. So now, once I've done formula, that's a mark on my short response if that was a short response question. I can now do part 4 of the 5 F's, which is find. Okay, so basically all we gotta do is just substitute now. Alright, very easy. And I like to put my times in just to really make sure I'm getting it in my calculator correctly. And then my R value, I like to put it in brackets if I'm ever squaring or cubing or doing anything special to that number, just to make sure that I'm doing it right. Okay, making sure that my signs, positive and negative, are all going to be cancelled out in the end as well too. That's why I use the brackets. Okay, and then I'm just going to get my calculator out quickly. And you should be using a graphics calculator for these questions. So we've got 6.67 times 10 times 65 times 75 squared. Okay, we can see that we have our value, and if we round it to 2 decimal places with scientific notation, we have 1.45 times 10 to the negative 7. Okay, and so that's our key value there. None of these options have the 1.45, so if as soon as you see a 1.45, that's when you know you gotta this is the right answer. So the answer is D. Right, question 4. 2 experiments were conducted and the following observations were made. Experiment 1 is light passing through a double slit produces a diffraction pattern. Okay, so that's Young's double slit experiment. And experiment 2 is above a specific frequency, light incident on a metallic surface produces photoelectrons with discrete amounts of energy. Alright, so forgot what the experiment was that was, but it obviously shows something different in terms of what light is, I guess, like defining what light is. Okay, so what statement can be supported by the observations? Well, this was a pretty, I guess, simple one. It was pretty self-explanatory. A wave theory of light can completely describe the nature of light. Usually with these sort of questions that are, I guess, completely or always or do never, those are usually wrong because there's always exceptions. That's another tip. So you can easily cross out A. The bending of light is a result of light behaving as a particle. Not necessarily, because the particle model, I think this was the particle model, and then this was the wave model. I guess if light is a particle, then it doesn't necessarily bend, because that's sort of more of a wave property. Okay, the particle model only describes some properties of light. You see, this is not one of those always, not, or never sort of statements. So you can sort of already know it's correct because it considers both the experiments here. So the particle model, which is experiment 2, is talking about a model of light, but it's not obviously consistent with experiment 1, but that's okay because we can conclude or make a statement that's supported by these observations in experiment that the particle model only describes some properties of light, okay, not all. That's the key thing. And only light waves can travel in a vacuum. It doesn't really mention that in this experiment. We can't really know that, but yeah, the best answer is obviously C. Question 5. The magnitude of the electrostatic force between 2 positively charged particles, and then you have your options to continue and finish that sentence. So when I'm thinking about the magnitude of the electrostatic force, I need to think of, okay, can I find anything in terms of, and two positively charged particles, can I think of what topic that would be? That would definitely be electromagnetism. Okay, so I have force, I have two charges, which is Q. And so what I would do is I would write that formula exactly on how it looks. Yeah. So there, I need to talk about what the answer would be. So I know that the magnitude, like the value of F, basically, electrostatic force, which is what this is referring to right here, between two positively charged particles, so I know these are both positive, is inversely proportional to the square of the distance between the particles. Okay, so this distance is r, squaring that is r squared. Okay, and so I can see my r squared there, and it's inversely proportional. Okay, inversely. So if you remember, if you watch my math methods video, my first video, I talked about relationships in equations. And so we have mainly two types of relationships, or three types if you want to, in physics. So I might just put them in terms of y and x. So we have this, which is like a direct or like proportional relationship. We have an inverse proportional relationship, and then we have a inverse square relationship. Okay, so we can note here that if we just get rid of everything, that all the variables that we're not concerned about, so everything but f and r squared, you can see that we have a f equals, we'll just say this red stuff was k, just like any sort of like factor in the front, and then over r squared, and we can see that the relationship between f and r is that they are inversely squared. Okay, and so that's what A is saying. So we know that A is correct, inversely proportional to the square of the distance between the particles. Okay, I think as well there's a definition of this in the QCAA glossary of the syllabus, again chapter 6 of that basically, if you have that memorized, it's very easy, because I'm pretty sure that's just the definition in itself. If we look at other options, like such as B, we know this is incorrect, because if the square of the distance between the particles increases, then by the inverse proportionality relationship, it doesn't have to be even talking about mattering about the square, but just the fact that they're inverse means that there has to be opposite changes. So this is actually supposed to be decreases. Okay, because in inverse proportionality, if one variable increases, the other must do the opposite, decrease, and vice versa. We know it's not proportional, it has to be inverse, because one of the variables is in the denominator of the fraction and is unrelated. So no, because it's in the formula. We know we have both F and R, which is the electrostatic force, magnitude, and the distance respectively. I call this one. This one is a graph. So whenever we see a graph in physics, we always think of gradient, gradient, gradient. Okay, so gradient, always use the gradient. Okay, it will always tell you what you need to know. Right, so just note the mass is not in SI units. Okay, we are in grams, and grams is something that is not an SI unit. It has to be in kilograms for an SI unit. So I'm going to take note of that. Okay, don't ever be fooled by that. Otherwise, you'll get values that are like 100 off. Such as these. You can easily recognize that they're trying to trick you here. We have 0.02 and 20. They don't just put them there for any reason. Markers and creators of these external exams will always put trap answers that they expect most people to get wrong because of some conversion factor they got wrong. Okay, so it's just good practice to write. You can still copy the numbers, just make sure you write the units so you know what you're working with. Okay, so I'll just read this part of the question. The graph shows a relationship between the masses of different objects and the gravitational force they experience on an unknown planet's surface. Right, so we have the masses of different objects, which is on the x-axis, and the gravitational force they experience on an unknown planet's surface. Okay, so we have the gravitational force here. Cool. All right, and then cool. All right, sounds good. So what I'm going to do is, on a graph, the first thing I usually do is just write the maximum and minimum points in terms of coordinates and try and find the gradient between them. Okay, it's better to find the gradient between the longest, I guess, like furthest away, sorry, the 2 points that are furthest away, rather than finding like a gradient that is using these 2 points. Okay, that's not going to give you the best accurate I suppose, like gradient or value that you're trying to find. Okay, especially because this line is done up very neatly with the dots hitting each line, but in like more complicated where the dots are like randomly put, you want to try and find the furthest like away points to each other to find that gradient that are on the line. Okay, so that's very important. It has to be on the line. Okay, the reason why we draw the line is because we need to use it. All right, so if there's other points like here in another question, don't use this point and this point, right? Don't use this point and this point. Okay, you must use the line that you draw, or that the examiner draws especially. You must use that line for the gradient. Okay, great. So just get rid of this stuff. Yes, so we have this max point, which is 2000 grams on the x-axis, comma 100, checking my units, is newtons. Okay, so I know this is mass and I know this is gravitational force, which I remember is capital F, right, in newtons. And then this one similarly, so I know that this is going to be 100, 200, 300, 400, 500. Okay, because there's 5 individual places, and 0 to 500's a difference of 500. If there's 5 different, I guess, divisions, I'm just dividing by 5 each. I guess division equals 100, so I know this is 500 minus 100, so that's 400 grams, comma 20 newtons. Okay, and so my gradient, so we talk about gradient equaling. Actually, I don't think we usually put lowercase m like we do in math for gradient. We usually just say gradient, because lowercase m can sometimes be mixed up with the mass, and you don't want that in physics. It's just too stressful. So gradient we talk about is the y2 minus y1 over x2 minus x1. Okay, I like to also put my x1, y1, x2, y2 labeled on my thing, my graph, my coordinates, just so I know that I'm doing it completely right. 100 minus 20, and those are newtons, so I just write that there. over x2 minus x1, which is 2000 minus 400,000 grams. Okay. Another thing I could do, actually, just erasing that bottom part, is converting these to kilograms. So I know that's just 2 kilograms there, because I know 1000 grams are in a kilogram, and so I'm just dividing 1000, or getting rid of 3 zeros in the end. So 2 kilograms, and this one is moving the decimal 3 places, is 0.4 kilograms. Okay. And the reason I do that is because when we're trying to find a gradient, we also want to make sure they're in SI units, so we're getting the correct values for those. Okay. So our x2 value is 2 kilograms minus sorry, I'll just put numbers in just not confuse us. 2 minus 0.4 kilograms. Okay, if I put that in my calculator, don't need to put units in, just 100 minus 20 over 2 minus 0.4, I get a gradient value of 50. Okay, so that you can obviously see that's a trap answer. It is not D. Okay, because a lot of people will go through all this working out, find the gradient 50, that's the right answer. Nope, it is not the right answer. Okay, so we need to first check that we are actually confident that it is the right answer. So first, what I do is I like to write just what units I use to find the gradient. So I know the gradient is y over x. I'm just changing y, changing x. Not really necessary because they just cancel out here. But I'm just really worried about the units. So gradient is equal to, therefore, the y we have f, and the x-axis we have mass, m. So I know that gradient equals f over m. Now from this, I look at what I'm trying to find. So the gravitational field strength is lowercase g, okay? And with lowercase g and capital Fm, I know, looking at gravity in motion, I'm trying to use this formula right here, okay? Cool. So I know that I can simply just say that the gravitational field strength, if I just rewrite that formula, g equals f over m, that's literally my gradient. F over m is my gradient. And so I can equate these two and say that my gradient is just literally g, lowercase g, which is the gravitational field strength, which we know is already 50. So I tricked you there. It is actually 50. I was getting a bit worried there if I had to restart, but really it's just about checking that it's the right answer, okay? I didn't really know what the gradient was until I actually checked, and so that's where I can actually confirm, yes, it is indeed 50 meters per second squared, or gravitational field strength. Okay, so 50 meters per second squared. And in terms of the units, they're all the same, so I don't really have to worry about them too much. But yeah, just making sure they're all consistent is important to get the actual value. I'll just quickly make a side note. If I did not convert my mass into kilograms, I'll just try that for a sec and show you what I mean by the examiners will always trick you with these multiple choice, the other options in the multiple choice. So if I just put in 2000 minus 400, because you know a lot of people can be careless, in my calculator I get a value of 0.05, and you can go through all this stuff about what the gradient is and everything, and say that, yep, okay, G gradient is equal to F over M, they're equivalent. All right, I know that it's, if I don't have the value here, 0.05. Okay, yep, that's B, right? I've already lost all my marks for this question simply because I didn't convert to SI units. And that's the importance of SI units. The question will never tell you to convert it to kilograms. In fact, none of the units say you had to. Okay? So that's a really important thing. All right. So yeah, just keep note of that. All right, cool. Inclined planes. So just going through what we've done so far. Question. All these are correct, and yeah, all the answers for the external papers are up as well, so you can check these as you go with your revision. It's really important to check your answers. That's what I found in year 12. Checking answers is really important to make sure that you're on track and that you're not falling for any mistakes and making them even worse, and I guess making those mistakes part of something you remember in your brain. You want to get rid of those mistakes in your head before it's too late to unlearn. Question 7. An object experiencing a gravitational force of 50 newtons moves down on a frictionless incline of 40 degrees to the horizontal. Calculate the net force acting on the object. Okay. Cool. So I know my gravitational force, which is capital F, is 50 newtons and a frictionless incline of 40 degrees. So I know my theta is 40 degrees to the horizontal. Okay. I don't think they ever done this as a trick question, but always remember to the horizontal is different to the vertical, right? Because I don't know, they might trick you in 2025 externals, we don't know. Okay, but just always making sure you read the question and writing down your facts. As you can see, I'm doing the 5 Fs now, and the figure stage is here. I know that I'm doing this correctly. Let's put this here. A pretty bad triangle, but I'll do what make. We're not artists again. Alright, and then this is a typical thing you gotta draw for any inclined plane. It's always gonna be the same, alright? So we know that force of gravity, so F subscript G is 50 newtons. Okay. That's very poor. I'm just going to increase that size. Yep. And then I know my F parallel and my F perpendicular. Anything else I need to know? I know G is 9.8. Magnitude of G is negative 9.8 meters per second squared. Yeah, because if we're assuming, and that's why it's important to write a figure, because the reason why we don't have negative is because I put a positive 15 newtons. But if I keep it as negative 15 newtons, then I obviously have to put negative 9.8 as my G. But I prefer to keep it all in positives, just making sure that I have my figure which shows that clearly. Okay. So I also like to put my arrows in my vectors. Very important, because vectors are both direction and magnitude. And I want to find the net force acting on the object. Okay. Cool. So in this case, I know that my theta value is always going to be this right here, between the gravity sort of force acting on the object and the perpendicular line to the plane. Alright, so I know that theta here is going to be 40 degrees because these are equal. And if you want a quick reason on why that is, I can quickly show you, just if it makes sense, if it doesn't make sense to you. So say we have an object, right? If I were to just make a line down here, this is theta, and this is right angle triangle as well. I know that this is 180, sorry, well, it not necessarily have to go straight to 180 because I know that there's already a right angle here, so I'm just going to make this 90 minus theta. Alright, and then from that I know that this triangle I'm making here, the smaller one, I'll just make this bigger. I know this I know this is a right angle, and I know that this entire, in red, I'm going to draw this in red, this entire line is 180 degrees. So I know that this entire line is 90 degrees. Sorry, this entire angle is 90 degrees. Okay, so it's a bit messy here, but if you just sort of understand that, like, this part right here is 90 degrees, because over here we always say it's perpendicular, so we make a 90 degrees angle. If this angle here is 90 minus theta degrees, this angle here, then I know this green value here, which is where I put my theta value here, is going to be question mark for the moment, question mark degrees, and that's going to equal a total of 90. So you can see here that if I just do a little bit of algebra, 90 minus theta plus question mark equals 90, and then I just move, I just cancel out 90 on both sides, so I'm negative theta plus question mark equals 0. Well, I know that question mark is therefore equal to theta. Okay, so my question mark, or the unknown green angle here, is literally theta. So it's basically equivalent there. So that's how I prove to myself that this angle right here is theta. There's other ways where you can just accept it and just memorize that, or you can just, I guess, be curious as well, because it helps you understand and remember them better if you're curious most of the time. Okay. So moving away from my little tangent, I know now that we were trying to find the net force, and if the object is moving down a frictionless incline, then I know that there's not any friction, there's no opposing force here. Okay, that's basically 0 newtons, non-existent. Okay, in a real world that's not real like that, but in physics questions they are, especially if they mention a frictionless incline. So there's no opposing force. I'm literally just trying to find this right here, the force parallel to the plane going down. Okay, and I know that I've defined going down as a positive value, so I can just work with positives there. All right, so using a bit of trigonometry now, I know, I can just memorize essentially that F parallel is equal to FG sine, because we are looking at the side that is opposite the angle. Okay, opposite sine theta. Alright, and then we have FG was 50 sine 40 degrees. Now making sure our calculator is in degrees mode and not radians mode. I'm currently in radians mode, so I'm just going to change that. Okay, because you will get a different value, and you will see most of the time, I'll check with this, that one of the options is literally a radians mistake trick value. Okay, so if I am in degrees, right, like right now, and I put in exactly that value, 50 sine 40, I get a net force, or the parallel force going down that the object experiencing is 32.1 newtons, which is A. Okay, I'm just going to quickly check the what happens if I am in radians mode. So yes, so this is so close together, yet it's very wrong. So if I were to put this into radians mode, so make sure you're in degrees. Okay, so just looking at that value, if I'm in radians, and I think there's even like a QCAA, they posted a subject report of physics 2024, and they literally showed the percentage of people who chose B, who chose C, who chose D, who chose A, and the right answer and stuff like that. I'm pretty sure quite a bit of people last year chose B, because literally because what happens, right, is your calculator, if you use a graphics calculator, it's always going to reset to radians mode. So you always have to be cautious about that. Okay, physics does not use radians mode as far as I'm concerned. Okay, it always used degrees, because that's, I guess, we're not really talking about pi or anything like that at this stage in year 12 physics. According to the QCAA syllabus, we're just working with degrees most of the time, or all of the time. And so if I were in degrees mode, I literally put in, like, try yourself. It is literally saying 37.3 newtons, which is this answer right here. Okay, and so you can argue and say, oh, my calculator said 37.3 degrees. No, you're wrong. Okay, you also lose all your marks for that question just by a simple mistake. Okay, always look at this value, the unit, degrees, and making sure your calculator is in the correct mode. Okay, now I'm going to change my calculator to degrees so I don't make my own mistakes. Okay, question 8. The net magnitude, an object is pulled in two different directions as shown. Not to scale. What is the magnitude of the net horizontal force acting on the object? So I'm talking about the x-axis values, right? So I know that there's a horizontal moving to the left, and also I can see, based on this imaginary right angle triangle, because I know that my vectors, one of the thought points in the syllabus, I believe, is noting that a vector always has vertical and horizontal components. So I know that this is just the if I say this is the F force, and I know this is just Fx, okay, and it's always going to be equal to, again, using my trigonometry, is F cos, because I'm using adjacent. Okay, if I remember saw, ka, toa, I know that sine is opposite and cos is adjacent. That's really all you need to know. I don't think we use tan that much. F cos theta. I know my theta value and stuff, so I can just plug that in. So that's 120 cos 60 degrees. Okay, and I believe that's going to be, just in my head, it's going to be 60, because cos 60 is a half. So just checking that quickly. Yeah, I'm right. Okay. Now, it's talking about the net horizontal force, but think of it logically. If one's pulling to the left and one's pulling to the right, do we simply just add them together? No. We need to put negatives to these values, and that's why there's a trick answer as well. So you can say as you can see, there's a big pattern in terms of these exams. They always like to put trick option answers. So if you put 30 plus 60, that's always going to be 90, but that is a trap answer, right? So we don't do that. And I guess when you're studying for these external exams, try and look for those tricky trap answers, because it'll show you, I guess it'll help teach you on what mistakes people mostly make and why or how to avoid them and stuff like that, you know. So I believe actually every sort of one of these answer options is supposed to be technically an answer trap, but I don't know if it's always like that for every question. But anyway, there's usually going to be like one answer trap, especially for calculation questions. So I'm going to I usually assign my positives for up and right and my negatives for left and down, because it's like a is it 4-quadrant plane, the Cartesian plane sort of thing. So I have therefore a plus 16 newtons to the right and a minus 30 newtons, which is going left. I don't really need my right and left arrow symbols because I already defined that by my plus and negative. So plus 16 newtons minus 30 newtons, or just if I like to sum them, I can still do that. I just have to keep my negatives in place. So 60 plus minus 30 is just going to be a net horizontal force of 30 newtons. Okay, and it's asking for the net, so it's really just a positive number because it's just asking you how much horizontal force is acting, like the magnitude of it. That's what it's asking, magnitude, not necessarily direction. So can't really stump up that direction part of the question, really. You just need to know that they're opposites, and one's bigger, so obviously if I'm pulling like a tug of war, 60 newtons of force to the right and 30 newtons on the other side to the left, then person who's going to win is going to be the one on the right. So I just do the 60 newtons minus the 30, big number minus small number. Alright, question 9. A passenger at the center of a train moving at relativistic speed switches on a light. According to the passenger, light travels outwards as shown. Right, so you can see on this diagram that I haven't drawn a person, but it's what it's referring to, okay? So there's a passenger, which I've drawn as a stick figure, on this train, and they observe the light turning on and traveling. So they're within the train and they're traveling to both ends. It seems like it's like basically simultaneous. Okay. So you can obviously know this is now the train paradox. Okay. So let's see what the question asks. How would a stationary observer watching the train pass them record this event? Okay. Now I know a couple of people who got this question wrong simply because they didn't read or look at the diagram. Direction of travel of train is going to the right. Right? So if you imagine the train going towards the right hand side of the page, and you're stationary on this platform here, you're this stick figure, seeing the train pass, where's that train going to be going by the time you've seen the light flash? By the time it reaches the one end of the train, it's going to obviously be more to the right. So if I just draw a very bad drawing, it's not going to really work. Yeah, it is what it is. If I'm a stationary and I see that train pass, but light obviously at constant speed, one of our postulates of special relativity, if that light just goes at the same speed, then I know that this end of the train, the back of the train is going to hit that light that was traveling it's gonna hit that light first. Okay, so it's a bit of an intuition sort of thing, where if the train moves, right, and that light just moves at a constant rate left to right, if this back of the train is going towards that light as the train moves, and you're a stationary observer, right, watching this train move, and if the train's moving basically at relativistic speed, it's going to be so fast that it catches up to the speed of light. That's what I like to think of it. It catches up to the speed of light. But what catches up? It's the back of the train, not the front, because the front goes away from the speed of light, which means that the light will reach the back of the train first and the front of the train last or afterwards. Okay, so our answer there is A. All right, and yeah, I guess another trick question here is that if you were talking about, if you didn't read this part about the stationary observer and you just talked about the passenger at the center of the train, then it can obviously be a trick question there, because I mean there's a bit of change in the question here. You know, we're talking about a passenger in the center of the train, and then immediately the question goes straight to a stationary observer watching the train pass by them. I think this is the main sort of key indicator that we're talking about this guy and not this guy. Okay, so if you were talking about the center person on the train, the station observer on the train, this is the correct answer, but it is not. Okay, so this is person on train, say observer, and sorry, I think it's more D. That's the right answer for this scenario. I don't really necessarily know about T0. I guess the light hasn't really turned on for T0, so that's just a bogus option. But anyway, the correct answer, what the question asking, is A. So yeah, I really just like to show the reasoning behind why every one of these options is right or wrong, because that helps me learn 4 times more than if I just focus on the right answer. And I hope that can help you as well, because who knows, the 2025 or future papers might have basically the same question, but will be asking about the person on the train, and therefore your answer would be D for that. Okay. Now this one was an interesting one. We never got any questions that in the past for our practice that had the order of magnitude of the strength. And I really just guessed this one, took an educated guess, and just relied what my graphics calculator told me as what the value would be for if I were in scientific notation. Okay, so anyway, an experiment was conducted to determine the force experienced by an 85 centimeter wire. All right, so just going straight to facts now. So I won't go straight to facts. I want to know what other variables I have, so I know what letters to use and what formula I might use. So 2.4 current flowing through it, an external magnetic field. Okay, so we're now into magnetic fields. It was rotated through varying angles within the magnetic field, such that data analysis identified the relationship. But F equals 0.0306 sine theta. What is the order of magnitude of the strength of the external magnetic field? All right. So I'm looking here into my formula sheet, just looking ahead on electromagnetism. Sorry, not electromagnetism. It would be, oh, where did it go? Here. Yeah, electromagnetism. And I can see that we have this, I believe it was this one, yes. So we have force, just checking strength of the external magnetic field. Yeah, we determined we have a force and we have a sine theta. So that's a dead giveaway that we are working with F sine theta, and BIL is what we're working with here. Okay, so you know, I guess with the 5 F's we can sort of start with the formula just so it's a bit easier on what variables we're using, and then making sure we go back to the facts, okay? Because they're obviously not watching you as you write, it's just making sure you get everything on the page. So I know 85 centimeters is 0.85 meters, the current is 2.4 A. Another thing with units is that you can, in a short response, I guess to show full working out, you can show the fraction method of converting your units, such as this method. I don't think that's yeah, so basically what I did is saying how many meters in 1 centimeter, and then putting the centimeters on the top and bottom to cancel out, and then timesing by this factor. So that's going to be 0.85 meters, which is what I put there. So that's just a way to understand converting. We just put the unit that we want, which is the SI unit, meters, lowercase m, for any sort of length. I think we're actually using capital L, so I'll just use capital L for now. I won't be using R because that's more like gravity stuff. Capital L is 0.85 meters. Yes, and so they like to put length of wires in centimeters because that's usually like the length of a wire, but making sure we can't use centimeters in our calculations. We have to convert it always to SI units in physics. Okay, and that's one of our facts. Anything else? We have this value here, and we can sort of, if we write these on top of each other, we can sort of equate these two. So equate these two formulas, and we get the fact that 0.0306 equals BIL. Okay, yeah, and then from that, have we drawn a figure? No, we haven't drawn a figure. So I guess we have a wire, and then we have a current flowing through it, and we have a magnetic field. It can be any drawing you want as long as you know what you're talking about, what topic we're on and stuff like that. Rotated, yeah, force. Okay, so yeah, I mean that's really just it, really. Figure's not really that important in multiple choice or this stage, but and then in our formula, I have these formulas and stuff, but what really matters to me is I want to find the order of magnitude. So just focus on one part of the question at the moment. So let's focus on the strength of the external magnetic field. Okay, so that is, we have to know that's capital B. Okay, so magnetic field strength is just capital B. Okay, and so we want to transpose this formula right here to make B on one side of the equation on its own. So I just divide by IL on on both sides, so therefore B equals 0.0306 divided by IL, our current times length, and then I just basically find now my fourth step of my 5Fs. So substitute them in, bring them in my formula. Not really working with any angles, so don't need to worry about degrees or radians. It'll give me the same answer. I have 0.015 T, capital T, which is Teslas, okay? And so it's sort of asking, it's a bit of a weird question. It's now asking about the order of magnitude, okay? Now, your calculator will say 0.015, but there's a setting, and you can search this up. My graphics calculator is dead, so I'm using a scientific calculator, but there's a way to figure out. I think in my scientific calculator, if you just do like a setup mode thing, and then there should be some section in your calculator where you can choose a scientific notation and how much significant figures you want from that. So I'll just try mine at the moment, just quickly. Yeah, so I got, yeah, so if you put in scientific notation mode sort of thing on your calculator, then it will give you this value. So scientific notation will give you 1.5 times 10 to negative 2, and it really depends, this value here really depends on how much numbers you round it to. My calculator specifically says 1.50 times 10 to negative 2 because I've clicked 3 as the number. You know, when you click that scientific notation function, I'm in the setup mode, it'll ask you for a number from 0 to 9. I press 3 and press enter, and that would give me 3 significant figures, but this one gives 2 if you clicked on 2 after the scientific notation function. And what I'm really worried about though is this right here. Okay, and there's ways to get to that answer without actually having to use your calculator, such as knowing that how to convert values to scientific notation, right? Which is, I guess, one of the first things I learned in physics in year 11, week 1. So that's crazy. They've basically used that assumed prior knowledge from year 11 to test on these sort of things. So I know here that my calculator, my scientific notation value, knowing that scientific notation, you have to have the main value at the front of the times by 10 to the something as a number between 1 and I think 9.9, just less than 10 basically. And so from there we can move our decimal point to a value that is within that range, which is 1.5, and then times by 10 to the, well, I move my decimal place to the right, making the value bigger, so my actual value is pretty small, so I'm doing negative. I did it 2 times, moving the decimal point 2 places to the right. Alright, and so that's what this thing is, the order of magnitude, okay? So that's what that's referring to. Basically a scientific notation form and saying what power of the 10 to the 10 are we raising for that. That's what we refer to as magnitude, okay? So the answer there is B. Just taking my answers as we go, so we know which ones are right and wrong. Okay. Question 11. A planet orbiting a star has an orbital radius of 6.4 times 10 to the 14 meters and completes a full revolution every 1.5 Earth years. What is the mass of the star? Okay. So I have a radius, so I'm just assuming that's going to be a little r. Hopefully I'm right. 10 to the 14 meters. Okay, I'm in SI units. Good. Completes a full revolution every 1.5 Earth years. So that's a period. Okay, which is a, if you look at your definitions in the glossary, period is capital T as a symbol, and it's in seconds. Okay, so Earth years. So I know, just making a side note here, that 1 year equals 365 days. Okay, that's what I'm assuming when I'm doing these physics questions. And a day has 24 hours times 60 minutes times 60 seconds. Okay, which in my head is 86,400 seconds in a day. Just checking that. Yes. And I'm still in scientific mode, but I don't really need to at the moment, so I'm just gonna do that. I'm still in. I'm still in scientific notation for some reason. A normal. Yeah, that's right. Okay, yeah, I'm right. And so from that, I need to know the mass of the star. So I'm assuming it's capital M because it's a really big mass. And yeah, I'll just have a look now at my formulas for specifically, what am I looking at? Gravity and motion. So I have T squared, 4 pi squared, R cubed, and GM. Okay, and I'm trying to find the mass of the star. Okay, so I can easily know that that's my formula. I'll just do a quick clarification using my figure stage of the 5 Fs. And so if you look up here in my 5 Fs, finalize the last step of the 5 Fs is really about units, making sure you're checking over your work as you go through, because sometimes we don't get time in the end. So, or like, I guess we just get lazy and we don't want to check our answers, but making sure we check them as we go through and making sure we're flowing through pretty well with no mistakes is how you can get 100% on these external papers, as I did. Alright, so I'm literally just gonna draw 2 circles. Sorry, just planet orbiting a star. Okay. And it's orbiting like that, and then the T equals 1.5 Earth years. I'm just going to convert that now. So 1 year is 365 days times 86,400 seconds per day. Cancel out days. I've got 86,400 times 365. It's going to be 536,000 over Earth year. So that's how many seconds in an Earth year. So I can cancel these out, and then times that by 1.5, I get 473,0400. Okay. So pretty big values there, making sure I'm got the correct values for them. Okay, and they should show in my multiple choice anyway. Okay, and then what I'm going to do now is I'm going to write down the formula that I was looking at. It's T squared over R cubed equals 4 pi squared over capital G, capital M. What I like to do in these ones is I like to, when I'm transposing, so this is probably one of the more complex transpositions and formulas you'll be using in physics. What I like to do is I like to put what variable I want to find. I circle it and I just put that at the top. So the way to put it at the top is really, if you have like 2 fractions like these, all you got to do is just flip them, both of them, okay? because essentially what you're doing is you're still keeping that ratio together. You just flip them. All right, this ratio right here being equal to this ratio is still going to be equal to this and this. All right, so from that I can just remove what's on the denominator of what I'm trying to find, again circling it. So times by 4 pi, so 4 pi r cubed over t squared equals gm. And another one of my facts that I know is that g equals 6.67 times 10 to the negative 11. And so let's tell I've been doing this for a long time. And so I just divide by that, put it in the denominator basically. So I'm just dividing by g on both sides, so I'm canceling those out. Okay, so therefore my mass of the star is going to be simply 4 pi r cubed over t squared g. Okay, and I like to always write it out. Okay, you get marks most of the time for literally substituting your numbers, so putting them in, writing them down on what you're putting on the calculator, not just putting it in the calculator and writing your final answer. Okay, you don't want to lose silly marks from being too lazy, because that will add up for every question, and then you'll yeah. So the orbital radius is 6.4 times 10 to the 14. I'm cubing that. Okay, a lot of the time people forget the cubed or the squared or mixing them around. You make sure you're getting that really correct. And again, SI units for time is always going to be seconds. Okay, so I'm not going to do it for this question, but I'm sure one of these options is a trap if you just use 1.5 as your time or period. So I'm going to be squaring that times by 6.67 times 10 to the negative 11. Okay, let's see if you can beat me on this one. Hopefully I actually get a value that works. Okay, I got 2.21, or just rounding it to the one decimal place, 2.2 times 10 to the 40. Now what happened here? I remember. I know now. I know what's wrong. I did not square my pi. Okay, so luckily I did not get full because it wasn't one of the options, but as you can see I'm a bit rusty here, so just forgive me for that. It's actually 6.9 times 10 to the 40. So that's a good test for you, seeing that the common mistakes that people make. You know, if this was a short response, then I'd basically be doomed. Okay, but anyway, that final step of the 5 F's, finalize, is really just looking at your calculator once you got your answer and saying, okay, did I do it correctly? And also looking at your working out. If I just had to look at these two lines up here, then I would notice that I forgot a squared for my pi there. Okay, yeah, so I guess it also is a bit tricky because you have I guess a 4 pi squared and then an r cubed, so it's like you thought that was just 4 pi r cubed, but no, it's just 4 pi squared times r cubed. Okay, so that's probably a bit of explanation why it can be tricky as well. Question 12. So what do we do when we see a graph? We find the gradient. Okay, so we can see that there's now dots not exactly on the line, but we never use those dots. Okay, we use the line we're given. All right, because that's the whole point of the using the line. All right, but hey, first of all, we don't know what the question's asking, so we might just waste our time finding a gradient and it might not mean anything. So horizontal displacement of an object experiencing projectile motion was measured and recorded against the cosine of the launch angle up from the horizontal. Initial velocity was kept constant. Okay. I honestly don't know why this question was here. It was a really, I guess, mathematical question. It wasn't really a physics one, but anyway, they like to put in these graph questions and making sure as physicians, physicists, you know how to work with converting and graphs and that sort of stuff. Okay, it's a big part of physics, I guess. So what launch angle would cause the object to land 1 meter from its starting point? Well, if I know 1 meter from its starting point is just horizontal displacement, which is what this question is all about up here, then I just know that Sx is equal to 1 meter, which is this value right here. So if I just draw a line and I hit that line and I go down to the cos theta of that angle, I can see there's 1, 2, 3, 4, 5. So this will be this distance here of 1.1. 0.1 is divided by 5, which is going to be 0.02. So this is 0.12. Okay, just 0.02 above 0.1. So I know my cos theta value is 0.12. Okay, but it's asking about the launch angle. So this is a trap answer. It's not A. All right, and I'm sure there's going to be a degrees radians problem trap here as well, but I'm not going to do it and show it, but you can do it yourself and see if there's a trap answer here. I'm pretty sure there is. But theta, and you can also see here as well that like it's not really like an inclined plane per se. If you have a angle of 0.12 degrees is a pretty like unreasonable angle to say. Like it's essentially just not even that. It's probably 1 degree, but like less than that angle right there. Like that's a pretty weird thing to say is an inclined plane. Whereas values like 83, which I'm more inclined to say like that, it's probably not close to 83 degrees, but you know what I mean. It's clearly defined as an inclined plane, so that's also another thing it's like a red flag. You can know if you got an answer like 1 degree, then you'll be like, huh. I think the reason it's a trap is because you just basically the one they got here, but that doesn't really make sense. It's this is meters, shouldn't have been degrees. But some people in stressful situations, they can get that, think that's the answer because they can't think as straight in high pressure situations, which is okay, but it's important to recognize that and to cope with that as well. So making sure that I'm in degrees mode now and finding my theta. It's literally like a math question, trigonometry. To find theta, I just to remove this cos, I have to take the inverse cos of both sides, so that'll just take care of this cos. And making this here, putting that in my calculator in degrees mode, I get 83.1. Just 83 is what we need degrees, which is D. Okay, which also confirms what I was intuitively thinking. Right, so we know we've got those two questions right. Light with a frequency of 9.4 by 10 to the 15 hertz is an incident upon an unknown metal producing photoelectrons with a maximum kinetic energy of 5.6 times 10 to the negative 18 joules. What is the work function of the metal? Okay, so work function. I'm thinking about capital W now. Frequency is just F. Last time I checked, and maximum kinetic energy is just EK, I believe. Yeah. So those are my facts. I'm not gonna rewrite them just because to save time. And my figure, well, I have light on frequency, unknown metal. You produce photoelectrons. So these are my photoelectrons here. And maximum kinetic energy there. Okay, just a quick figure, but really what really matters is the formula here. So that's going to be, if I look in towards the electromagnetism, or no, I think it was quantum theory. Yeah, quantum theory is going to be EK equals HF minus W. Okay, now just easily transposing for W to be on one side of the equation, I'm just going to plus W on both sides. So I have this, and then W equals HF minus EK. Okay, so essentially just swapping these two around. Alright, and I know H is, I think it was 6.626 times 10 to the negative 34. Just gonna check that. Yeah, cool, I remember. Times 10 to the negative 34. Alright, and making sure I'm all in SI units, joules, hertz. That's not necessarily in joules, sorry. But it's a complex unit, but don't really need to know. As long as these are SI units, then I'm all good. Okay, and I know my work function, it's going to be an EV for these multiple choice options, so I need to keep that in mind as well. Alright, so I have 6.626 times 10 to the negative 34 times the frequency, which is 9.4 times 10 to the 15 minus kinetic energy maximum 18. Okay, time to use my calculator. Making sure I'm doing this all correct. No errors. Okay, and I get 6.2844 times 10 to the negative 19. Now a lot of people go straight to, oh, that's D. No, because they think it's 6.3 when they round it to one decimal place. No, that's incorrect. All right. Immediately, I don't think it's 6.3 because we're talking about EV, and this work function is in joules because we've been working with hertz and joules and stuff like that. Our H, the Planck's constant, is in joules and seconds, so definitely not, and hertz is actually per second. Fun fact, joules per second is the function there, and so if we just keep our units together, so joules per second and 9.4 actually I think hertz is seconds. Joules, no, sorry, never mind, this one was not per second, so joules times seconds. This one is hertz per second. This is just S, and this one minus 5.6 times 10 to the negative 18 joules. So you can see here that the seconds will just cancel out with timesing seconds times seconds to the negative 1, just cancels out to second to the power of 0, which is just 1. So working in joules, okay? But none of these answer options have joules, so it's definitely not D, because we need to convert it to a factor that isn't 1. It was actually this here. So this is important. It's year 11 content, assumed knowledge, but it is really important. Actually, it is the same value, but this is more of an accurate what you need to know. This is also year 11 assumed knowledge, but 1 eV is equal to 1.60 times 10 to the negative 19 joules. Okay. So if I know that what 1 eV is equal to 1.60 times 10 to the negative 19 joules, and I can say that if I just simply divide this by 1.6 times 10 to the negative 19 joules per eV, then I know that I'm canceling these joules units and I'm moving this eV on the bottom denominator because it's a -1 power. I'm moving it to the top. It's bit of maths there, revision, but as long as you know that we're dividing by 1.6 times 10 to the negative 19, that factor goes from joules to eV, then you should be all good, because it makes sense. Like if we're timesing it by 1.6, then there's kind of no point, because you're making an even smaller number with a 10 to the negative 38 value, and none of these options have that. It's like a nice, I guess the reason we work with EVs is because it's like a nice number to work with rather than numbers to 10 to the negative 19, and so that's why we divide to try and cancel off these 10 to the negative 19. That's how I like to remember it. Okay, because we're essentially now just doing 6.2844 divided by 1.6. Okay, you don't even need to write down those 10 to the negative 19 to save time if you wanted to. And so our answer there is going to be 3.9. Okay, so the answer there is B. All right, check that. Moving on, this is just rote learning again. So syllabus knowledge. Question 14, magnetic flux density is a quantity related to the number of magnetic fields per unit area. Okay, here. Right, that's it. And again, as I said before in previous questions, we have the symbol, the SI unit. Right, it's given there. You should know it. Memorize them. Memorize all the definitions that are in the dot points for your syllabus, and like for any subject really, physics, chemistry. I didn't do biology, but I'm sure biology has that as well, or psychology, another subject. Okay, so you have to memorize the exact meaning, the definition of them, because they'll literally, you can see it's literally a carbon copy, okay, of those exact words. But also understand what they mean as well, because as you can see in the next question, it's not exactly carbon copy. In a way, it's trying to get you to understand certain parts of the definition and making sure you get the right answer for these multiple choice questions. Okay, what I have done as revision back when I was in year 12 is I made it used to be called quizzes, but now it became Wayground for some reason. And what I did is I went through every past external exam question for physics through Exam Insights, which is a website I used. I even bought a membership for that. And I basically, what I did is I filtered out all the past external exam questions that were defined cognitive verbs, and I basically ticked every definition that was part of the syllabus that has been tested, and I noticed that they never seem to repeat questions this was back in last year when I was doing my external exams. They never seem to repeat questions from past papers, but actually, interestingly, they did repeat like basically the exact same question in some of these. I think this was a repeated question from a previous paper talking about magnetic flux density and the definition of that. it could be differently like worded, like obviously different options, but I mean they can. We seen it that they can repeat questions, so it's important to make sure you do every external exam question as much as possible as you can before your externals. So yeah, as I was saying, I'll put the link down to that. I'm happy to share that Wayground quiz link, where I basically from the list I made about past external exam questions in the define cognitive verb, I ticked off every definition we needed to know from the dot points that were already tested, and the ones that were not tested, I put them into a quiz with multiple choice. It's like a fun like learning I guess app or website, I really like to call it, and it will, yeah, I hope it really does help. I put some extra information there as well in terms of the direction stuff, or like you know, when you use those right angles with your fingers, and the like solenoid stuff. It was interesting because the paper for 2024 never actually used those right angle finger things. Maybe they found that it's not a very nice question, because it can be a bit ambiguous there with what the directions are really. Different textbooks say the different things and all that sort of stuff. It was very stressful, but thankfully it was not a question that was on last year's paper, for my paper. But anyway, I'm happy to share that resource with you. It basically, yeah, just carbon copies the definitions of the like glossary that hasn't been tested prior to 2024, and makes them into multiple choice questions that, you know, can, I guess, sort of replicate what might potentially be on an external exam paper in the future. So that's what I wanted to share there. Same thing here. So it's a bit similar, but this is specifically asking in which direction does the centripetal force act. So if you already memorize the centripetal force, I believe this is also in my Wayground quiz that I'm going to put up in the description below. If you memorize this here, then you can instantly know that it you know, puts the direction is towards the center of motion, which is carbon copy what is literally the answer. Okay, so that's a quick, easy one. Question 16, standard model. Yeah, it really is just rote learning at this point. I mean, like, you learn it and then just forget about it after. Yeah, I didn't really remember much, to be honest, on like with 100% accuracy on standard model, which is why I have a diagram here. I try to find the table that I printed out, like, you know, I told you in the first question I had printed out and, you know, put on my bedroom wall and stuff. I tried to find one that's similar, for that will be really good for this question, but unfortunately I don't have it. Stack students from my school, hope you guys have it in your OneNote, so you can use that. It's just basically a table that shows like different baryons or photons, and it shows you everything you need to know, like the strength, like what forces they mediate and stuff like that. That's definitely something that really helped for these sort of questions. It was literally like so useful for answering this sort of table question where you had to like basically tick which row is correct, because yeah, I mean, these are the mediating particles and forces that they experience. So this one, photon, I believe there's no strong nuclear force because it's just only the gluons. Okay, so it's not a lepton, same thing. I mean, you really need to put a tick on the electromagnetic force for leptons because they have a negative charge and stuff like that. For those like electrons, so electron is one of the leptons, so no, not really. Quark, I mean, quark, it's yeah, it has a strong nuclear force and electromagnetic force, but I mean, everything has the weak nuclear force, so I don't know why they didn't tick it here. So that definitely is wrong. So by process of elimination, it has to be meson. And a meson, just quickly here, is just a quark anti-quark pair. So if you think of quarks having everything, the strong nuclear, weak nuclear, extramagnetic, then by, I guess, intuition, you can see that a meson, which is just a quark anti-quark pair, will have the same sort of features. They'll have a tick here, tick here, tick here, just like what was supposed to be for C, the C row. So it is D, the answer. Yeah, there's really just rote learning. Okay, and for question 17, a person on Earth experiences a time period of 15 years. Approximately how much time will have passed for a passenger on a spaceship traveling at 0.7 times the speed of light relative to Earth during that time? So I like to, with these time dilation questions, draw a figure in the second step of the 5Fs first, just to show and see which one's going to be my T0 and which one's going to be my T. Okay. We have a rocket ship. Okay. And it's just sort of person on it is there, and they're just traveling towards the speed of light, maybe away from Earth. Okay, so the person on that passenger, the passenger on that spaceship is going to see Earth moving away. So in other words, they're going to see Earth moving away from them, okay, because they're stationary on that spaceship. And so that means Earth, or the person on Earth, is going to experience time dilation for them. Okay, so that's going to be in terms of the passenger's frame of reference relative to Earth during that time of travel at 0.7 c, which is relativistic speeds near the speed of light. We can see that the person who is time dilating from their frame of reference, this person I've circled, is going to be actually the person on Earth. Okay, which means that the person on Earth experiences a dilated time of 15 years from the spaceship's frame of reference. Okay, another way you like to think about it is that if you're traveling near the speed of light, you're going to experience time much more slower. Okay, because like compared to someone who's just stationary and letting, who isn't moving at all, right? So if you remember the twin paradox, you can also know that the twin who was traveling is going to be younger than the twin who was on Earth. Okay. Another way I like to think about it is if you travel at exactly the speed of light, you'll actually not change in time. That's why it's sort of like impossible to travel the speed of light, because basically if you travel the speed of light, no time will have passed from the time you started moving to the time you stopped moving, right? And so that's another way to think about it. So I guess the closer you get to the speed of light, the younger or the less time you will take to travel that than someone who is an outsider and observes you from a stationary position, right, and sees you moving, right? And so yeah, you'll see there that we are trying to find our T0, which is the stationary passenger in the spaceship relative to Earth. All right, so we just use our formula now. On the formula sheet, the third step of the 5Fs, we have this right here. There's not really any other formula we can use. Let's just use that. T equals T0 on square root of 1 minus V squared over C squared. Now, for these time dilation questions or any special relativity questions with a V squared over C squared, I like to do it by hand because putting 0.7 C as a speed sometimes doesn't really come to mind on what to do. It can be a bit confusing. So, but the math really cancels out well in these sort of special relativity questions. So I'll show you how. But first we need to transpose. So we're trying to find T0. And so therefore T0, we're just bringing this, multiplying the fraction, the denominator on both sides to get rid of it. So if we're timesing by that on both sides, we're going to get T times the square root of 1 minus V squared over C squared. Okay, and that's equal to T0. Right, so we just substitute our values in now, exactly how it is. We know that V equals 0.7 C, and then we see what happens. So 15 is our T value, times square root of 1 minus, I put in brackets again for the square, 0.7 C, squaring that over C squared. So you can see here by sort of algebra, if I square each of these terms, I get 0.7 squared, which is 0.49 C squared over C squared. These C squareds cancel out, and we have a nice number we can put in our calculator now, 1 minus 0.49 in the square root underneath that. So 1 minus 0.49 there. And then we just plug that in our calculator. That's all we need to do to make that work. And we get an answer of 10.7 years, okay, which is about 11 years in the question, the multiple choice options. So answer is B. Okay, everything was in SI units, so that's fine. Yeah, so I guess with time in terms of, well, you don't have to convert it to seconds because we're not working with seconds anyway. So sometimes exceptions to the SI unit rule. But yeah, if you're talking about spaceship traveling, you're not really talking about seconds, are we? You're talking about, years, because that's when we can really just see a defined change in time. 4 years apart, basically, which is quite insane if you think about it. Electromagnetic waves are produced by an oscillating electric charge resulting in an interaction between magnetic and electric fields. How are these two fields aligned? Well, again, from our syllabus glossary, we can just memorize this definition, all the ones in the dot points that we need to know, and we just know that electromagnetic radiation is radiant energy consisting of synchronized oscillations of electric and magnetic fields, which is what we're talking about here. Two fields that are aligned are synchronized oscillations there, basically. Okay, so all these are correct. Right here, just gonna tick them now. Cool. Question 19. Another, what is order of magnitude? So we're going to use our 5Fs. So we have a charge. Let's say that's Q. Let's talk about charge 7. This is, what was this symbol again? This was micro. Yes, so 10 to the negative 6. So what I like to do is, because my SI units for charge is coulombs, I like to just change that to 7 times 10 to the negative 6 coulombs, because that 10 to the negative 6 is just basically what this micro symbol means. Okay, just converting it, because I don't want to use the actual number 7. I want to use this exact SI unit value for this correct SI unit for my charge. Energy seems fine in joules, and because I'm trying to find the potential difference between the 2 points in electric field, I'm looking at electromagnetism formulas, and I'm seeing, I'm trying to find voltage there, because voltage is talking about potential difference. Okay, so that's my V equals something volts. Okay, that's an easy one to remember as what the unit is, and the symbol, they're just both capital V, volts. And so I can draw a figure if I wanted to, just saying I have a charge and I have 2 points in electric field. I want to move it and it requires energy. Alright, so what's my symbol for energy? It was delta U, which is also in joules. So knowing these different symbols in your formula sheet is also important. So I'm just doing facts and figure at the same time. And yeah, I've done all my facts, figure. Now my formula is really just V equals delta U, or change in energy, over Q. Everything's in SI units, so I just do 1.5 times 10 to negative 8 over 7 times 10 to negative 6. I can see there that it's leaning towards an answer of D. So I'll just put that in my calculators just to check. I should automatically get it into, actually no, it's not going to be D, my bad, because we're minusing a negative, so it's going to be around -2, -3, but yeah, we get an answer of 2.1 whatever, 4 times 10 to negative 3. All that matters is that this 10 to negative 3 value is what I really need. Okay, and again, definition, I'm going to say it again, but just memorize the ones that you need to know, the dot points. Okay, defining feature of black body, yes, this one right here. Okay, black body is a perfect absorber or emitter of radiation. Okay, all frequencies of electromagnetic radiation are absorbed and emitted. Okay, all these are, yeah, the light does not have 2 wavelength peaks. If you remember that graph, it was something like that, but there's only 1 peak. Okay, so this is 1. Electrons are emitted in the presence of all frequencies of light. No, because you need to be above the work was it the threshold function? Work 0 or something like that. I don't remember, but yeah, this, I believe the work function was the minimum required energy, which leads to a minimum required frequency to actually release an electron. And so that's wrong. Indeed, the peak of its spectral output does not vary with temperature. Actually, temperature is one of the, I think if you have multiple graphs, they're like actually variable with temperature changes. So yeah, I did my IA3 on that, so that was pretty helpful as well. But yeah, 20 is really the answer. It's given to you in the glossary, so really just use that glossary to the best of your ability there. Alright, so yeah, that is the external exam for 2024, the multiple choice paper. Let me know in the comments if you do want me to go any through specific papers. Otherwise, I'll just be going through what I feel like doing and that I feel can best help. So that's a 20 out of 20 that I got for this paper. Also during my external exam, which, yeah, that's that. Thank you very much for watching, and I hope you enjoyed and learned something from this.